Welcome to the first video in our series where we'll do an introduction to number for grade 7 maths. We'll move on from the puzzle. First thing you need to do is pause the video, have a go at watching this particular video that I've listed here, and you can see this guy here talking a little bit about algebra and how it's useful. Okay, so where are we up to? This is our work rate calendar. We're in week 1, so this is our activity that we're starting at the moment in our unit on number. Alright, so week 1, lesson 1, index notation. Okay, an index is a very short way of writing big numbers. The thing you need to understand is that there's a base. So in this scenario, the base is 2, and we have an index, which is the little 4 up there. Now, if we look at 2 times 2 times 2 times 2, you could work that out. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16 is what the number actually is. But we can shorten that and write it like this, where we say 2 to the power of 4. It's like there is 1, 2, 3, 4 of them. So 4 is the number that goes up there as the index, or the power. So 2 to the power of 4. It's not particularly useful when our number's only 16, but as our numbers get very, very large, it starts to make a big difference. All right, so when we read these numbers from index notation, this is the kind of thing we do. When there's to the power of 2, like we've got there, we say, in this case, it's 10 to the power of 2, or 10 squared. Okay, because it means 10 times 10, which is like the area of a square that would be a side of 10, 10 times 10. 10 to the power of 3 is 10 cubed, because that's like the cubic 3D shape. So 10 cubed, or 10 to the power of 3, and after that we just say 10 to the power of 4, 10 to the power of 5, and so on. Okay. We can represent other numbers using index notation. So in this scenario here, we've got 9 times 10 to the power of 4, and that's how we say it. So it's 10 to the power of 4 is 10 times 10 times 10 times 10, because there's 4 of them, and that works out to be 10,000. 10,000 times 9 is 90,000. It's another way of writing it. Doesn't look too useful when you've got a number like 90,000, but as the number gets larger, it becomes increasingly more important. All right, so here's some examples. Write the following numbers using index notation. In my first example here, we've got 5s, so my base is going to be a 5, and I say how many of them are there? 1, 2, 3, 4, 5, 6, 7. So it's 5 to the power of 7, and that's all there is to it. 5 is the base, 7 is the power or the index. In this scenario, the next one down, we'll deal with the 3s and the 7s separately. So I'm going to have 3 as one of my bases, and I'm going to have 7 as one of my bases, and everything is multiplied. Now, how many 3s have I got? 1, 2, 3, 4, so it's 3 to the power of 4. I've got 1, 2 7s, so that's 7 squared. So it's 3 to the power of 4 times 7 squared. Same scenarios that we've got here. If we look at this number 1, A, 5 times 5 times 5 times 5 times 5 times 5, all that. 5 is obviously my base, and my index is how many of them there are. There's 7 of them, so 5 to the power of 7. All right, and in part B, it's the same one again, just like we did. 3 to the power of 4 times 7 squared. Okay. All right, let's go on. All right, we can simplify each of the following numbers by first writing as a repeated multiplication and then in index form. So they're the two things we need to do, repeated multiplication and index form. So what does that mean? So the first one we've got is 3 to the power of 4 times 3 to the power of 6. Okay, 3 to the power of 4 is this bit here. 3 times 3 times 3 times 3, because there's 4 of them. 3 to the power of 6 is this one here. And because it's a times in there, it's a times in there. All right, we don't need the brackets on the next line here, okay? And you can just see that they're all 3s, All right, so my base is 3. And how many of them are? You count them up, there's 10, so my index becomes 10. Okay, in the next part, we have 4 to the power of 3, or 4 cubed, all cubed. So what this means here is what's inside the brackets has got to then be cubed. So we've got 4 to the power of 3, or 4 cubed, written down 3 times. And then on the next line, we expand each one of those. So this one here is a 4, so they're all 4s, and there's 3 of them written there because there's a 3 there. And then that's done 3 times. All right, remove all the brackets and let's count up how many we've got. The base is obviously 4, and if you count this list here, there's 9 of them there, so 4 to the power of 9. Same with the next one. It's 3 times 5 squared. So we've got 3 times 5 times 3 times 5. There's 2 of them because it's to the power of 2. We then remove the brackets and write it out neatly. We've got 3 squared times 5 squared. Okay, these next ones are done exactly the same as that, just what we did. 3 to the power of 4 times 3 to the power of 6. Okay, so 3 to the power of 4. 1. Whoops. 4 of them. Oh, my mistake. It's easy to do. There's a 3 as my base, so I've written it out 4 times because that's the indice. Times 3 to the power of 6. So I want to write out 3 6 times. 1, 2, 3, 4, 5, 6. Okay, they're all 3s. 3 is my base. How many have I got? If I count them up, that would be 10. What you actually notice is that that's the same as 3 to the power of 4 plus 6. 4 plus 6 is 10, 3 to the power of 10. That's kind of a little shortcut. All right, you can have a go at these ones. These ones are all reasonably similar. I will pick a couple that'll do. I'll do these ones down the bottom here. All right, I've got 5 times 5 times 2, 2, 2, 2. All right, so I'm going to have 5 as one of my bases and 2 as the other one. I have 2 5s, so it's 5 squared, and I have 4 2s, so 2 to the power of 4. 5 squared times 2 to the power of 4. My last one down the bottom here, I've only got 113 times 5 is the next base I'll have. I have 3 of them, 1, 2, 3, so that's 5 cubed, times 7's the next, and I've got 2 7s, so it's 7 squared. Okay, I'll skip over these next ones, but you can work through them at your own pace. Okay, so remember, index notation. It's a short way of writing repeated multiplications over and over and over again. The number being multiplied is what we call the base, and the number of times it's been written is the index or power. And that's why we sometimes refer to these as indices, because that's an index. All right, when you have a look at the Pearson textbook, you'll notice these sections here. I'll just quickly outline those. The first section is this fluency. It's basically basic introduction, like the first question I did as an example up earlier in the video. The understanding section, those questions come next. That's kind of, you want to head towards a B rating. If you can do all the fluency ones, then you're definitely on track for a C. If you can do all the understanding ones, then you're on track for a B. If you can do all the reasoning ones, you're heading towards an A. And the open-ended questions are the really, really hard ones, definitely A-level questions. So when you have a look at the exercises, so in this case here, we've got 1.2 indices is what you can have a look at. You can see down here, the first section is fluency, and then question 1 starts right below that. Have a go at the middle column there where the arrow is pointing. Just try those questions. Ask your teacher if you've got any questions. Thanks a lot.